Hello students, we're going to be going over section 1.4, reasoning and proof. So first thing just to point out, conditional statement is an if-then statement. Whatever comes after the if is the condition. Your hypothesis is whatever comes after the then is your conclusion to it. So if I looked at if 3x minus 5 equals 13, this right here, this whole part right here, this would be our hypothesis. And then x equals 6, that would be our conclusion. Okay, so as we look at it, we're going to be setting up a lot of if-then statements throughout the year. Our reason for proofs is to show why it's the case, not just to say, yeah, that's the case. So when we come through here, properties that you've been working with for a while is the addition property. So these ones, addition, subtraction, multiplication, division. These are all properties that you've used regularly. What they say is if I add, so if I have two sides of the equation, like here, A equals B, I have two sides of the equation. If I add to one side, if I add C to one side, then I need to add C to the other side. And that's what you get here. If you subtract C, then you need to subtract C to the other side. If I multiply by C to one side, I got to multiply by the other side. And then if I divide by C on one side, I have to do it to the other. So those are all properties that you've dealt with pretty regularly throughout the time. You've never really explained it out. The new properties, and these are properties that I really want to highlight that you're going to see throughout the rest of the time here. The reflexive property, transitive, symmetric property, transitive property, and substitution. Now, the reflexive property is, let's say I have an angle that looks like this. And then let's say I have another ray that comes in here. And so let's say we have points A, B, C, and D. Okay? So you have these points. Now, if I were to look at these two triangles, I have two different triangles. And I could say that in these two triangles, so if I say here, I had triangle ABC, and I also have triangle. I have angle ABC. Not triangle, there we go. I have angle ABC, and I have angle. So I have an angle ABC, and I have angle CBD. Now, what we can say is we can draw a conclusion is that this side BC is equal to BC. And the reason why is because it's the same line. It's right there. So that's the idea of the reflexive property, is that when we have this common side or common angle, we know that they're equal because it's the same side. So now we go on to the reflexive property, or excuse me, the symmetric property. The symmetric property says, like basically this is the idea. If I say that A is equal to 3, I could say A equals 3, or I could write it as 3 equals A. I could switch the order. It's okay to switch the order of things. And so we'll see this property kind of throughout as we switch things. The transitive property is what I call is you need three things. So you need an A, a B, and a C. So I'll do it this way. You need three different things. So you have 1, 2, and then 3. What you notice is that you have two different statements. So I have a statement here, statement here. We want to turn these two statements into one statement. And how we do it is by tying the middle values together. So basically, if A equals B and B equals A, we can cancel off B, and we have that A equals C. So this transitive property is this idea of three statements, and how can we break it down into, or if we break it down into one statement. And then lastly, substitution property. You've done this before. What you did before in like algebra 1 is y equals x plus 5. And then you have another equation, 2x plus 3y equals 6. We said, hey, if y equals x plus 5, we can plug it in for that y right there and rewrite the equation 2x plus 3 times x plus 5 equals 6. And now you can solve it as you go through. So those are just things to point out to you. What we're going to do is we're going to go ahead and solve. And when we solve, we're just going to justify our step. So here I would add 4. So I'd say that this is the addition property. of equality. And so that equals 18 equals 3x. And then when I divide by 3, hey, that's the division property of equality. And that cancels off, and you get 6 equals x. All right, but the big thing is naming it. So that's what we're looking to do as we go through. So if I were to do this one over here, I come here, I subtract 3. So this would be the subtraction property of equality. So then I would have negative 4x equals negative 8, then divide by negative 4. And again, we'd have the division property of equality. And so x is equal to 2. So that's what we're going through. Write the statement as a conditional statement. All zebras belong to the genus Equus. So it's a if, okay, we could say if the animal is a zebra, then it belongs to the genus Equus. Okay. Next thing, just a couple things to point out. If two angles form a linear pair, so this would be a theorem that we're going to use. So if they form a line, if these two, if I connect it and they form a line, then these two angles, 3 and 4, are going to add to 180. That's what we're saying. So we'll use that property, okay, when we set that up. Okay, if I look at this right here, so given RT equals 5x minus 12, they actually give us here, so R to T, so they say given that this whole line is equal to 5x minus 12, we want to use the postulator theorem to find the value of x in each figure. So what we would say is that RS plus ST equals RT. And then this is the line segment addition. So it's just what we've gone through. So if the two smaller parts will add up to the whole thing. And now, instead of saying RS, what does RX actually equal? It equals x plus 2. ST equals 3x minus 8. And then R to T equals 5x minus 12. This would be our substitution property. And now we're going to combine like terms. X plus 3x is 4x. All right, plus 2 minus 8 is minus 6. And then 5x minus 12. So you could say grouping like terms here. And now we can solve. So I'd subtract 4x. So this would be your subtraction property of equality. And so you get negative 6 equals x. And there you have it. Now I could switch the order. And let's say I switch the order. And I said x equals negative 6. Then this right here would be your symmetric property. So it's a matter of going through and stating it. I'll do this one as well. If I look at this one, okay, they have RST, this whole angle, equal is right there. So we can say that angle RSP plus angle PST equals angle RST. Again, this would be now angle addition. Postulate. Okay, now what is RSP? What's the value of RSP? That's x plus 25. What is PST? PST is 5x plus 10. And then RST, R to S to T, which was up here, was 15x minus 10. And so again, this was substitution. We combine like terms, so x plus 5x is 6x. 25 plus 10 is 35. Okay, and this was grouping like terms. And now we solve. So we subtract 6x. So this would be the subtraction property of equality. And so we would get 35 equals 9x. Then we add 10. Oops. Minus 10 here. 9x minus 10. So then we add 10 here. And so this would be the addition property. Addition property of equality. So you get 45 equals 9x, then divide by 9. And so now we just use the division property. So kind of pretty straightforward as far as how it goes. You just have to, each step that you do, you have to give a reason for why you did exactly what you did. So as we go on to the next one, okay, so just the postulates that we'll use throughout it that you'll kind of draw your information from, okay. Through any 2 points, there's exactly one line, okay. Through any 3 non-collinear points, there's exactly one plane. So plane, again, is that piece of paper, that idea behind it. And so when you look at these properties, if 2 points lie in a plane, then the line containing those points lies in a plane. Each one of these will be properties that we'll use throughout the end of the year that we'll look at and go through. So that's just the beginning of kind of the proofs that we'll start with. Is pretty straightforward as far as explain each step that you take.